Assalamualaikum warahmatullahi wabarakatuh. Good morning. Today we continue our lecture with chapter 3, numerical method. Okay, this chapter consists of 3 subtopics, which is 3.1, solution of non-linear equation, 3.2, Newton-Raphson method, 3.3, trapezoidal rule. This morning, I will cover these two subtopics, which is 3.1 and 3.2. Okay, we start our lecture with 3.1, solution of non-linear equation. At the end of this topic, students should be able to locate approximately a root of an equation by graphical consideration or searching for a sign change. Let's try a few examples here. First example, solve x squared minus 4x minus 5 equal to 0. This is quadratic equation. So you can solve this equation by factorization. And we get the root x equal to 5 and x equal to negative 1. Second equation, solve x cubed minus 8 equal to 0. This is cubic equation. So you can move 8 to right hand side and we get x cubed minus 8. Then we cube root both sides and we get the root x equal to 2. Third example, x cubed minus e to the power of x equal to 0. As you can see, this equation are combination of cubic and exponential function. Okay, so let's say we move e to the power of x to right hand side and we can see clearly x in both sides. So we cannot find the root of the equation. Based on example we done before, we can say that most of non-linear equations which occur naturally have no exact root. For this case, the approximation for where the root lies has to be found. Many equations cannot be solved exactly, so we have to turn to numerical method to solve them. So dari sini kita boleh faham ada certain equation kita boleh cari root, ada certain kita tak boleh cari root. So yang tak boleh cari itulah kita akan gunakan kaedah berangka iaitu numerical method. Okay, what is initial value? In order to use the numerical method, we need to get the first approximation to the root of the equation. So initial value is first approximation. The notation of first approximation either x null or x1. The initial value of the root of fx equal to 0 can be located approximately by either graphical method or algebraic method. Okay, how to determine first approximation by graphical method? There are two ways of graphing. Either plot or sketch the graph of y equal to fx. The real root are the points where the curve cut the x-axis. Okay, for example, saya bagi contoh kat sini. y equal to x cube. So awak sketch the graph curve y equal to x cube. When the curve cut the x axis, so here the root. Okay, or rewrite fx equal to 0 in the form fx equal to gx. Plot or sketch y equal to fx and y equal to gx. The real root are at the same point where this graph intersect. Okay, for example, e to the power of x plus x minus 2 equal to 0. As you can see, it is a combination of exponential and linear function. So you can move x minus 2 to right hand side. So e to the power of x equal to negative x plus 2. Okay, so you can sketch these two functions separately. One is y equal to e to the power of x, another one y equal to negative x plus 2. So we sketch the graph. Here y equal to e to the power of x, and here y equal to negative x plus 2. So there is the root, because the root is intersection between two curves. Okay, exercise 1. On the same axis, sketch y to the power of negative y equal to x minus 1 and y equal to x plus 1. Show that the equation ln x minus 1 plus x plus 1 equal to 0 has only one root. Okay, soalan suruh awak sketch dua equation. So first kita kena simplify equation yang pertama ni dulu. Sebab e to the power of negative y, so kita nak bawa y tu turun ke bawah. So we ln both side and we get ln e to the power of negative y equal to ln x minus 1. So we apply log law. So we get y equal to negative ln x minus 1. Okay, another equation is y equal to x plus 1. So we sketch the graph. Here y equal to x plus 1 and here y equal to negative ln x minus 1. Okay, so kita dah settle lah untuk sketch graph. So sekarang ni, how to show the equation has only one root. Okay, so kalau awak tengok kat sini, persamaan ni kalau awak perasan lah, persamaan ni adalah gabungan kedua-dua persamaan yang diberi ni. So let's say this is a first equation and this is second equation. So we equate first and second equation and we get negative ln minus 1 equal to x plus 1. And now we move negative ln x minus 1 to right hand side and we get ln x minus 1 plus x plus 1 equal to 0. So kita dapatlah persamaan yang soalan minta. So disebabkan persamaan ni adalah daripada gabungan dua fungsi di atas ni, so kita bolehlah guna graf ni. Okay, so pada graf ni kita nampak there is one intersection between these two curves. So we can conclude that the equation ln x minus 1 plus x plus 1 equal to 0 has only one root. Okay, exercise 2. By sketching the graph of y equal to x cubed and y equal to 3x minus 1 on the same coordinate axis, show that the equation x cubed minus 3x plus 1 equal to 0 has 3 real root. So dekat sini awak ada dua fungsi, iaitu y equal to x cubed and y equal to 3x minus 1. So now we sketch the graph y equal to x cubed and y equal to 3x minus 1. Okay. How to show the equation x cubed minus 3x plus 1 equal to 0? Sama seperti tadi, kita ada y equal to x cubed. So this is first equation. And we have y equal to 3x minus 1, this is second equation. So we equate first and second equation and we get x cubed minus 3x minus 1. So nak samakan dengan equation yang diberi pada soalan, we move 3x minus 1 to the left hand side and we get x cubed minus 3x plus 1 equal to 0. Okay, so maksudnya kita bolehlah guna graf yang kita dah sketch ni. Okay, so kalau awak nampak, there is 3 intersection point here. First intersection, second intersection and third intersection. So kita show lah the equation has 3 real root. Okay, how to determine first approximation by algebraic method? By try and error, find two values a and b such that fa and fb have different sign. At least one root must lie between a and b if fx is continuous. If more than one root is suspected between a and b, sketch y equal to fx. Okay, so kat sini maksudnya kita cuba jaya saja, gantikan dua nilai. So kalau ada perbezaan sign, different sign ataupun opposite sign, so adalah root di antara dua nilai tersebut. Okay. So now we move to exercise 3. Show that the equation x cubed plus x minus 4 equal to 0 has a root between x equal to 1.3 and x equal to 1.4. Approximate the root of two decimal places. Okay, so first we have the equation x cubed plus x minus 4 equal to 0. So first step, we let fx equal to x cubed plus x minus 4. Then we substitute x equal to 1.3 into fx expression and we get negative 0.503. So this value is less than 0. Next, we substitute x equal to 1.4 into fx and we get 0.144. So this value greater than 0. Since f1.3 and f1.4 have opposite sign, so there has a root between 1.3 and 1.4. Okay, how to approximate the root? How to approximate the root? Okay. To approximate the root, we can take any value between 1.3 and 1.4. So maksudnya kat sini, kalau awak nak approximate root, boleh ambil apa-apa nilai dari 1.3 hingga 1.4. But usually we take average between two values. Selalunya kita akan ambil purata di antara dua nilai. Contoh kat sini 1.3 dengan 1.4, average dia adalah 1.35. So dekat sini approximate root is equal to 1.35. Okay, kalau awak kata awak nak letak approximate root ni sebagai 1.2, 1.2 pula. 1.32. So tak ada masalah sebab dalam range ataupun interval 1.3 hingga 1.4. Okay, we proceed our lecture by subtopic 3.2. At the end of this topic, students should be able to find the root by the Newton-Raphson method. Okay, if x1 is a first approximation to the root of the equation fx equal to 0, then second, third, so on approximation are given by the formula xn plus 1 equal to xn minus fxn divided by f prime xn for n equal to 1, 2, 3 and so on. Repeat this process until the desired accuracy is obtained. Okay, so they have 4 steps to approximate root by Newton-Raphson method. Okay, first we let fx. Second, we differentiate fx. Third, we substitute first approximation x null or x1 lah, first approximation into Newton-Raphson method. Newton-Raphson formula, sorry. Okay, Newton-Raphson formula tu yang mana? Yang ni lah. Yang saya dah highlight dalam box ni. So ini adalah Newton-Raphson formula. Tapi dia akan berubah mengikut awak punya fungsi fx dengan f prime x lah. Okay, yang keempat, repeat this process until we reach repeated value. Okay, now we move to exercise 4. Show that the equation x cubed plus x minus 6 equal to 0 has a root between 1 and 2. Using the Newton-Raphson method with the starting point 1.6, determine an approximation to this root, giving your answer to 3 significant figures. So first sentence from this question, the question asks you to show this equation have a root between 1 and 2. So macam mana nak tunjuk ada root tak di antara 1 dan 2? So awak boleh guna 2 kaedah lah, sama ada graphical method ataupun algebraic method. Paling senang kita guna algebraic method. So first we let x cubed plus x minus 6 equal SFX. Okay, then we substitute x equal to 1 into fx, we get -4. So this value less than 0. Next, we substitute x equal to 2 into fx and we get 4. So this value greater than 0. Since f1 and f2 have opposite sign, so the equation has a root between 1 and 2. Okay, for the second sentence, the question asks you to approximate the root by using Newton-Raphson method with starting point 1.6 and you have to give your answer in 3 significant figure. Okay, so dekat sini kita dah tahu kaedah yang kita nak guna adalah Newton-Raphson method. Starting point ni adalah initial value ataupun first approximation. Lepas tu jawapan mesti 3 angka bererti, 3 significant figure. Okay, first step we let fx equal to x cubed plus x minus 6. Okay, second step we differentiate f prime x equal to 3x squared plus 1. Third step, we substitute first approximation into Newton-Raphson method. Okay, D is starting point, so D is first approximation. So we substitute this value into Newton-Raphson method formula. Okay, Newton-Raphson formula. Okay, now from this case, fx ini adalah yang ni lah, f prime x adalah yang ni. Okay, so saya tulis Newton-Raphson method, Newton-Raphson formula yang baru adalah xn minus 3xn cubed plus xn minus 6 divided by 3xn squared plus 1. Okay, so we substitute 1.6 into this formula. So x2 you get 1.635. Okay, kenapa jawapan saya bagi 4 angka bererti? Okay, so dekat sini soalan memang minta 3 angka bererti, tapi pada calculation langkah pengiraan kita ambil 4 angka bererti, maksudnya kita kena extra lebih 1 lah. Kita just round off the value on the final answer. Okay, now we substitute this value into Newton-Raphson formula and we get 1.634. And then we substitute this value into this formula again and we get 1.634. Okay, so dekat sini awak perlu tunjukkan 2 langkah pengiraan, iaitu kaedah awak gantikan nilai dalam persamaan Newton-Raphson method. Ni untuk markah kaedah lah. Okay, bila awak dah tulis 2, untuk x yang seterusnya, root yang seterusnya dah tak perlu tunjukkan jalan kerja. Hanya tulis jawapan akhir saja. Okay, so we stop our calculation here when we reach repeated value. Kalau awak tengok kat sini 1.634, kat sini pun 1.634. So kita stop lah calculation sebab kita dah jumpa nilai yang repeated, berulang. Okay, so kita dah boleh buat conclusion x equal to 1.63. Jawapan akhir je kita round off to 3 significant figure. Okay, exercise 5. Use Newton-Raphson method to find an approximation value for cube root 15. Give your answer correct to 3 decimal places. So kalau awak tengok pada soalan tak ada beri apa-apa equation. Hanya dia suruh awak cari approximate value of cube root 15. So kita dah tahu approximate value tu adalah root x. So dekat sini x equal to cube root 15. So from that we cube both sides and we get x to the power of 3 equal to 15, and we move 15 to left hand side and we get x cubed minus 15 equal to 0. So kita dah ada lah persamaan kubik ni. So sekarang ni kita bolehlah let fx equal to x cubed minus 15. Okay, so kita dah ada persamaan, tapi nak guna Newton-Raphson method mesti ada first approximation. So macam mana nak dapatkan first approximation? Kita try and error lah untuk cari dulu root tu berada kat mana. So sekarang ni disebabkan dekat sini root kita adalah punca kuasa 3. So kita tahu 1 is equal to cube root 1. 2 is equal to cube root 8. 3 is equal to cube root 27. So cube root 15 is in between cube root 8 and cube root 27. So the root cube root 15 may lies between 2 and 3. So maksudnya kemungkinan besar root tu berada di antara nilai 2 dan 3. So kita kenalah uji dulu, betul tak root tu berada pada nilai 2 dan 3. So kita guna algebraic method untuk uji dia. Okay, so fx equal to x cube minus 15. So now we substitute 2 into fx and we get negative 7. So this value less than 0. Next, we substitute x equal to 3 into fx. So we get 12. So this value greater than 0. Since f2 and f3 have an opposite sign, so the cube root 15 lies between 2 and 3. So confirm lah kata cube root 15 tu berada di antara 2 dan 3. Okay, so sekarang ni barulah kita boleh gunakan kaedah Newton-Raphson method. So let fn equal to x cube minus 15. Second step, we differentiate fx, so we get 3x squared. Then we substitute first approximation into Newton-Raphson formula. So for Newton-Raphson formula, the new formula is xn plus 1 equal to xn minus xn cube minus 50 over 3xn squared. Okay, so kita substitute 2.5 into this formula and we get 2.4667. Okay, soalan minta tadi 3 decimal places. So kita kena bagi extra lah 4 decimal places. Okay, now we substitute this value into formula. Maksudnya we repeat the process and we get 2.4662. Okay. So we repeat this process again. We substitute this value into Newton-Raphson formula and we get 2.4662. Okay, kenapa saya tulis 2 je dalam kerja? Sebab saya dah kata awak perlu tulis sekurang-kurangnya 2 dalam kerja. Tapi kalau awak tulis lebih, tak ada masalah. Okay, untuk X yang seterusnya maksudnya hanya tulis jawapan sahaja. 2.4662. Okay, so kalau awak tengok kat sini, we reach repeated value. Kita dah jumpa dah 2 nilai yang sama. So we stop our calculation here and we can make the conclusion X equal to 2. So cube root 15 is approximate to 2.466. 3 decimal places. Okay, sebelum saya lupa, okay, saya terang sikit kita memang dah tahu root tu berada di antara 2 dan 3. So mungkin ada certain kawan-kawan tanya, boleh tak saya tak nak guna first approximation sebagai 2.5, saya nak guna 2.3. Okay, sebenarnya tak ada masalah sebab saya dah kata bila root tu di antara 2 nilai, awak boleh ambil apa-apa nilai di antara 2 nilai tersebut. Maksudnya kat sini root kita di antara 2 dan 3. So boleh pilih apa-apa nilai di antara 2 hingga 3. Nak guna 2 pun boleh, nak guna 3 pun boleh. So maksudnya first approximation ni terpulang pada awak lah, awak nak guna nilai apa. Tetapi selalunya kita akan guna average of these two value, 2.5. Okay. Cuma yang membezakan adalah mungkin dekat sini, kalau saya guna 2.5, saya X yang keempat saya dah stop. Saya dah dapat jawapan. Kalau awak guna 2, mungkin awak akan berhenti pada X yang ke-9 atau ke-10 baru awak boleh dapat jawapan. Itu je beza dia. Jalan kerja tu akan jadi panjang ataupun pendek sahaja. Okey, sebelum kita pergi ke soalan seterusnya, saya ajar dulu macam mana nak guna calculator. Okey, so sekarang ni awak masukkan dalam calculator. First awak kena turn on the calculator dululah. Okey, lepas tu awak kena masukkan, enter the Newton-Rhapson formula into calculator. So formula tu nak dapat mana? Inilah formula yang awak buat tadi ni. So kita masukkan dulu formula ni dalam calculator. So awak boleh tekan alpha x minus bracket fraction form. So alpha x shift x squared minus 1/5 turun ke bawah 3 alpha x squared. Pergi ke kanan, tutup kurungan. So awak kalau awak guna calculator kelas Swiss ni, awak memang boleh masukkan formula Newton-Raphson ni sebiji dalam calculator. Exactly. So awak dah masuk sebiji. Okay. So sekarang ni kita akan tekan press button CALC, calc. Okay. So dia tanya x equal to, so substitute first approximation, nilai pertama lah 2.5. So press equal. So dia akan keluar color gelap. So color gelap ni hanyalah nak tunjukkan nilai x yang awak masuk. Tekan lagi sekali equal. So awak akan dapat 37/15. Okay, untuk untuk numerical method, jawapan your answer must in decimal. So you have to convert fraction form to decimal form. So tekan ni as to D ni. So you get 2.4666 ni. So awak just ambil sekadar 4 titik perpuluhan. Okay. Untuk second step ni, we press calculate. So tadi adalah nilai yang 2.5 yang first. So tekan answer. Answer ni adalah jawapan yang sebelum ni tadi. So press equal. So awak boleh nampak lah ini adalah jawapan yang sebelum ni tadi. So one more time, lagi sekali tekan equal. So awak akan dapat 2.4662. So ini adalah x3. So we repeat this process again. So calculate, answer, equal, and you get 2.4662. So kita stop kat sini lah sebab we have reached repeated value. Boleh? Okay, now we move to exercise 6. Sketch the graph of y equal to e to the power of x and y equal to 2 minus x where x less than 2 on the same axis. Sketch the first approximation x null for the equation e to the power of x equal to 2 minus x where x null between 0 and 1. Hence, by using Newton-Raphson method, solve the equation of e to the power of negative x equal to 1/2 minus x for x less than 2 to 3 decimal places. So untuk soalan pertama, dia suruh awak sketch graph. So awak boleh terus sketch lah untuk y equal to e to the power of x. And the second graph is y equal to 2 minus x. Okay. So sekarang ni awak dah bikin graph. So get the first approximation x null for the equation e to the power of x equal to 2 minus x where x null between 0 and 1. So maksudnya kalau awak nampak e to the power of x sama dengan 2 tolak x ni adalah gabungan dua fungsi yang berasingan tadi. Dia hanya gabungkan persamaan tersebut sahaja. So maksudnya kita boleh guna graf ni lah. So graf kalau nak tepat, nak cari first approximation, kena plot atas kertas graf. Baru awak boleh dapat nilai yang tepat. Kalau sketch mungkin tak tepat. So dari sini kita nampak point of intersection here. So first approximation is between 0 and 1. Ini di antara 0 dan 1. Okay. So sekarang ni soalan ni kata hence by using Newton-Raphson method solve the equation e to the power of negative x equal to 1 over 2 minus x. So kalau awak tengok persamaan ni, dia tak sama dengan persamaan yang diberi kat atas ni. So maksudnya awak kena simplify dia dulu. Bagi sama baru awak boleh guna graf ni lah untuk root kan. Okay. So e to the power of negative x equal to 1 over 2 minus x. Okay, so awak turunkan e to the power of negative x ni ke bawah untuk positifkan power dia. So dia ada 1 over e to the power of x equal to 1 over 2 minus x. Okay, so kita compare atas ni benda yang sama, so we compare the denominator. And we get e to the power of x equal to 2 minus x. So this equation adalah sama seperti yang awal-awal tu. Okay, so dari sini kita nak guna Newton-Raphson method. So kita kena move all to one side, another side 0. So we move 2 minus x to left hand side. So e to the power of x minus 2 plus x equal to 0. So now we have the fx lah. Okay, so first we let fx equal to e power negative 2 plus x. Second step, we differentiate fx, so we get e to the power of x plus 1. Third step, we substitute first approximation into Newton-Raphson formula. So the new Newton-Raphson formula is xn plus 1 equal to xn minus e to the power of xn minus 2 plus xn divided by e to the power of xn plus 1. Okay, now we substitute this value into Newton-Raphson formula and we get 0.4439. Then we substitute again this value into Newton-Raphson formula and we get 0.4429. Repeat again this process and we get x3 equal to 0.4429. So we stop our calculation when we reach the repeated value. So you can make the conclusion x equal to 0.443. Okay. Okay, exercise 7. Show that the equation 2 sin x minus x equal to 0 has a root between x equal to 1 in radian and x equal to 2 in radian. Find the root of equation by using Newton-Raphson method, giving your answer to 2 decimal places. Okay, soalan pertama dia minta awak tunjukkan persamaan ni ada root ke tak di antara 1 and 2. So first we let fx equal to 2 sin x minus x. Second, we before that remark, in numerical method, always use radian in all the problem involving trigonometric function. So maksud kat sini bila dia melibatkan, awak jumpa dia fungsi trigo dekat sini, tak kisahlah gabungan trigo ataupun trigo sahaja, pastikan kalkulator awak dalam mode radian. Kalau dalam mode degree, jawapan awak kan salah lah. Okay, so next we substitute x equal to 1 in radian. So we get 0.6829. So this value greater than 0. Next we substitute x equal to 2 into fx and we get negative 0.1814. So So this value less than 0. Since F1 and F2 have different sign or opposite sign, so there has a root between 1 and 2. Okay. Okay, untuk second sentence, the question asks you to find the root by using Newton-Raphson method and give your answer to 2 decimal places. Okay, first we let fx equal to 2 sin x minus x. Second, we differentiate f prime x equal to 2 cos x minus 1. Third, we substitute first approximation into Newton-Raphson formula. So the new one formula is xn plus 1 equal to xn minus 2 sin xn minus xn divided by 2 cos xn minus 1. And we get 2.077. Sebab soalan minta, the question asks 2 decimal places, so we give 3 decimal places in calculation instead of calculation. Okay, so we repeat again, substitute this value into Newton-Raphson formula and we get 1.911. And repeat this process again, we get x4 equal to 1.896, x5 equal to 1.895, x6 equal to 1.895. So we stop our calculation because we reach the repeated value. So the required solution is x equal to 1.90. So we round off to 2 decimal places. Okay, so that's all for today. So I see you in next subtopic on Tuesday. Thank you.